see here this value will be 0 and this value is also 0. Then Norton's current IN is equals to 30 amperes, right? Okay, step 1 is over, calculation of Norton's current. Next, step 2, across these two terminals I need to calculate Norton's equivalent resistance. Okay, while calculating Norton's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit. If the circuit is having current source, that should be replaced by open circuit, right? Here the circuit is having current source, that is replaced by open circuit. Okay, here I am calculating Norton's equivalent resistance across open circuited contacts, right? Here current source is replaced by open circuit, 10 ohm, five ohm. Here I need to calculate equivalent resistance between these two terminals, right? Next, here it is 2 ohm, 1 ohm, 1 ohm, right? Assume A and B terminals. Okay, now here I need to calculate equivalent resistance between A and B terminals, that is equals to Norton's equivalent resistance. Now observe this figure. Open circuit in series with resistance is neglected, then the equivalent circuit will be like this. This resistor will be removed, 5 ohm. I can write this A and B terminals as outside. Okay, here 2 ohm. Next, here 1 ohm and 1 ohm are connected in parallel, then the resultant value will be 0.5 ohms. B, here 2 ohms. These two are connected in parallel, right? 1 into 1 by 1 plus 1, you will get 0.5 ohms. That is, these two resistors are replaced by single resistor, that is shown here. Here this value will be 5 ohm. After that, 2 and 0.5 ohm are connected in series, right? Then the equivalent circuit will be like this, 5 ohm and 0.5 ohms. Okay, that is 2.5 ohm, A and B, right? Then Rn value will be 5 into 2.5 by, these two resistors are connected in parallel, right? 5 into 2.5 by 5 plus 2.5, that is 7.5. 2.5 threes are right. Then Rn value will be 5 by 3, right? 5 by 3 ohms. Okay, next, step 3. Okay, draw the Norton's equivalent circuit, that is IN from step 1, right? Rn from step 2. Okay, remove resistance from step 1, that is RL. Here RL is equals to, what is the value? 5 ohm, right? Okay, that is represented here, 5 ohm. Rn value will be 5 by 3 ohms. Okay, next, Norton's current is 30 amperes. Okay, then here I need to calculate current flowing through 5 ohm, right? Then IL is equals to, these two are connected in parallel, right? Then current flowing through load resistance is nothing but total current into opposite parallel branch resistance divided by sum of parallel branch elements, that is 5 plus 5 by 3, right? In this way you will get load current value in amperes. Okay, if you simplify this equation, you will get the load current value. Okay, in this way we can solve the problem. Okay, right? Next we will solve another problem. Okay, determine the Norton's equivalent circuit. Okay, that means we need to calculate Norton's current and Norton's resistance. That is sufficient for this problem. Okay, to calculate Norton's current, step 1, remove the load resistance RL. Already here load resistance is removed, right? Hence we can short these two terminals. Okay, short those two terminals and calculate short circuited currents. that is equals to Norton's current, right? Short circuit those two terminals. This is ISC or IN, right? Under short circuited condition, potential will be 0, right? Here point and here point will be same. That means here potential will be 0 volts. It is minus plus 50 volts, 3 ohm, 4 ohm, right? Then apply KCL at this junction. Apply KCL at 0 volts, right? At this 0 volts point, 0, assume current will be I1, I2, already ISC is there, right? Apply KCL at that junction, you will get I1 plus I2 plus IN is equals to 0. All are outgoing currents, right? I1 is nothing but potential difference will be 0 minus 50 by 3 ohms, plus I2 is nothing but 0 minus 0 by 4 ohms, plus IN is equals to 0, right? Okay, now see here, this value is 0, then Norton's current IN is equals to 50 by 3 amperes, right? Norton's calculation of Norton's current is completed, right? Next, step 2, across these two terminals I need to calculate Norton's equivalent resistance, right? While calculating Norton's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit. If the circuit is having current source, that should be replaced by open circuit, right? Your circuit is having only voltage source, that is replaced by short circuit. 3 ohm, right, and 4 ohm. Here I need to calculate across A and B terminals. Here I need to calculate Norton's equivalent resistance, that is equals to, here 3 ohm and 4 ohm are connected in parallel, then Norton's equivalent resistance will be 3 into 4 by 3 plus 4. I will get Norton's equivalent resistance value will be 12.7 ohms. After that, draw the Norton's equivalent circuit, that is step 3. Okay, that is Norton's equivalent circuit consisting of current source, that is already calculated, right? Current source, that is equals to 50 by 3 IN value amperes, in parallel with Norton's equivalent resistance, that is 12 by 7 ohms, right? If you mention RL value also, no problem. Okay, if you leave the circuit diagram like this also correct. Okay, in this way we can calculate Norton's equivalent circuit problems. Okay, thank you all.